Hey everyone, welcome to today's lesson about writing function rules. After today's lesson, you should feel very confident about writing functions for real-world situations. Let's go ahead and dive right into the first example. In the first example, we're looking at insects, and it says you can estimate the temperature by counting the number of chirps of the snowy tree cricket. It's pretty interesting if you ask me. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in a minute. What is the function rule that represents this situation? All right, to attack this problem, the first thing we need to do is decide what our variables are. It looks like the first variable is the outdoor temperature, and the second variable is the chirps of the cricket. So we'll say our variables are T and C. T is for the temp, and C is for the chirps. All right. The key words in here, it says the outdoor temperature is. The temperature is. Is that word that means equals in math. So we can say the temperature equals 40 more than 1/4 the number of chirps. So 1/4 the number of chirps is 1/4 C, and 40 more is plus 40. So the function for the number of chirps that tells the temperature is T equals 1/4 C plus 40. All right, let's look at another example. We're looking at a concert venue, and we're looking at the revenue they can bring in from the number of seats. It says a concert seating plan is shown below, and that's this beautiful picture. The reserved seating is sold out, so it must be a good show coming to town. The total revenue from ticket sales will depend on the number of general seating tickets sold. Okay, underlining that important information. It says write a function rule to represent this situation. What is the maximum total possible revenue? All right. So since the reserved seating is already sold out, let's figure out how much revenue has been generated from that reserved seating. There are 10 rows and 12 seats per row for a total of 120 seats. Each ticket costs $25, so we can do 25 times 120, and we find out we've already sold $3,000 from the reserved seating. Okay, let's go ahead and identify our variables. R is the revenue, and T is the number of tickets. All right, so to figure out the total revenue, it's going to be what we've already made, the 3,000, plus the number of seats in the general seating. So it looks like I've got 30 rows and 16 seats per row. So we've got 30 times 16. So there's going to be a total of 480 total seats up there. All right, but since we're talking about revenue, I'm more interested in this $10 per seat. So the actual revenue is going to be $3,000 plus $10 per ticket sold. Now, to figure out the maximum revenue I can get, well, I'm going to plug in the number of seats up there, that 480. So 3,000 plus 10 times 480, and that's 3,000 plus 4,800 for a grand total of $7,800 in revenue. There you have it. Let's look at one more example. It says we're trying to write a function rule for the area of a rectangle whose length is 5 more than its width. Then we're going to try to find the area of the rectangle when the width is 9 feet. All right. Again, let's identify our variables, and we'll talk about what the area formula is. So the area formula is the length and the width. It also tells us that the length is 5 more than the width, so we can say that the length equals the width plus 5. And we can take what L equals and substitute it into that original equation. So we are left with only 2 variables. Okay, so if I take W plus 5 and plug it in for L, I see that the area is going to equal W times W plus 5. And when I simplify, I have to distribute that W. So W times W is W squared. And then W times 5 is 5W. So the function rule for the area of that rectangle is the area equals W squared plus 5W. Now, what's going to be the area of that rectangle if the width is 9 feet? I'll go ahead and plug it in. The area equals 9 squared plus 5 times 9. The area equals 81 plus 45. So the total area is going to be 126 feet squared. All right, let's turn the page and we'll give you an opportunity to try some of these questions. Let's take a look at the self-quiz. Try all 3 questions, write your function rule, and answer any after questions, and then check your answers. For the first question, it says Tom's Tires has 628 tires in stock. Each day they sell 80 tires. So let's identify the variables. I've got S to represent my stock, and I've got T for tires sold. All right, so the stock is going to equal 628, and it is decreasing by 80 every time tires are sold. So there is my function. All right, how about number 2, where a plumber charges a service fee of $50 plus $35 per labor hour? So it looks like they want X to be our hours, and then C can be our total cost. So the total cost is going to be that initial fee of $50 plus $35 per hour. Remember that per means multiplication, so per hour, 35x. If the job takes 6 hours, well, that means that the cost is going to be 50 plus 35 times 6, so the total cost ends up being $260. All right, last one, number 3. We're talking about the area of a triangle whose height is 6 more than the base. We think back to what the area of a triangle. The area of the triangle is 1/2 the base times the height. So if the height is 6 more than the base, that means the height equals the base plus 6. I can take what the height equals and plug it in, so I'm only left with 2 variables. So I'm going to take b plus 6 and stick it in for h. So a equals 1/2 b times b plus 6. Now I have to be careful when I am simplifying because I am distributing 1/2 b to both terms inside the parentheses. So 1/2 b times b is 1/2 b squared, but don't be squared of this question, by the way. And 1/2 plus 1/2 b times 6 is 3b. So what is the area of a triangle whose base is 10 feet? I'm going to plug it in. So A equals 1/2 10 squared plus 3 times 10. That gives me a final answer of 80 feet squared. I can also look at this in terms of a picture. This would be my height. So if the base were 10, the height then would have to be 16. And I could do 5 times 16 and I would get 80 as my final answer. Alright folks, hope you learned a lot today. Let's come to class ready to work.